Hello and welcome to PlatformCon 2023. As platform engineers, we engage our thought processes in understanding and creating solutions for a problem space that has a great impact in the productivity of any organization. However, sometimes when we think that we have made life easier for others is when our systems tend to think otherwise, and they present us with yet another challenge that motivates us to redefine our benchmark of best. I am Diganta Mukherjee, and I am a lead software engineer of the engineering platforms and architecture team at Lowe. Today, I will take you through our journey where we faced an issue that was lying dormant in our systems and how it got triggered as the platform's usability increased. Finally, we will also look at how we fixed the issue. But first, let's have a quick peek into the problem space that our platform intends to address and the scale of our operations. Lowe's is a Fortune 50 company, second largest home improvement retailer in the world. We have presence both online and we operate across 1700 stores across the US. On an average, Lowe's serves around 17 million customers every week. Our team ensures that critical engineering platforms can operate at scale and support these stores, which act as mini data centers and form a distributed hybrid cloud. Some of our internal teams need to capture, track, visualize, and report various online and in store business metrics in real time. This in turn helps improve the entire ecosystem and takes us one step closer to delivering an omnichannel experience, which is a very critical element of our total home strategy. So, we built Pharaohs, which is a data visualization and reporting platform that enables data visualization and reporting over real time data. Pharaohs, as a platform, provides three core benefits to its users. The first one, real time user monitoring. This is a capability that can be integrated into any web or mobile application, and it helps track various performance error and custom metrics. It enables application teams to find out issues even before the customer notices them. The second feature is called real-time device monitoring. This is a capability that enables capturing various metrics from the devices that are used across our stores. Now, these are business critical events that provide us with actionable pieces of information and help maintain the smooth functioning of low stores. And the third one is data visualization and reporting. Now, with all the data that we have collected, the users need to perform queries on large data sets to extract various business intelligence metrics and generate reports on them. Using this platform, we can capture time series events and visualize various metrics in the form of dashboards and reports. As of today, Pharos has close to 100 tenants. We have around 3,500 users. That's serving around 8 terabytes of data in our cluster that constitutes 54 billion events. And we are ingesting more than 500 million events every day. The tenants of Pharos have built around 1600 dashboards, which are built using 12,000 plus charts. And these charts, in turn, query data from the cluster. All of these dashboards are actively used by our tenants to visualize and report their real-time metrics. Now, from platform team perspective, all of this sounds exciting and sounds like a success, right? But let me tell you a horror story that we lived through a few days prior to last year's Black Friday Cyber Monday sales period. Our users experienced a complete outage like scenario, and their charts and dashboards stopped working for an hour, even though the real time ingestion was up and running. To understand the chain of events that led to this downtime, let us go back in time and trace the journey of Pharos till the state when this outage had occurred. Pharos was built on a shared tenancy model with a fair and equitable distribution of resource among its tenants. Through this, we were able to share resources to optimize the cost of operating our platform. The key components include a Node.js-based backend service, an MQTT-based pipeline for device data ingestion, Apache Druid as a persistence layer, and Apache Superset as the visualization layer. Now, the initial process of tenant onboarding was quite tedious, and it required a lot of manual intervention from the Pharos team admins. Now, this increased the time to market for all the reporting and analytics need of various internal product teams. We wanted to resolve this. So, the team started building self-serve capabilities into the platform, which removed a lot of these manual interventions needed by the platform admins. This turned out to be a turning point from the platform adoption perspective, and it catapulted our tenant base to 2x year on year. Several new teams got onboarded. Their number of charts, dashboards, and users started increasing rapidly over time, and a lot of complex queries were being computed by the platform for rendering a wide array of visualization. And a few days prior to BFCM, bang, everything went for a toss. Our tenants started reporting a system-wide outage. What just happened? We thought we had built a highly usable and scalable platform. Well, apparently we had not considered the fact that the end users of any system can and will do anything the system allows them to do. Due to the nature of the data, most of the queries were aimed at getting a real-time view of the system, and they could be categorized as interactive queries which are fast-running in nature. There were, however, some tenants who were using a little bit more complicated queries and for their visualization and reporting. These queries were long-running in nature and had multi-level subqueries. When such long-running queries were fired by these users, it started depleting the thread and connection pool to a point where the query started to fail and the resources were depleted and starved completely. Furthermore, these users started retrying these queries, these failed queries that were powering their dashboards. And what happened is this eventually caused the outage by triggering a retry storm. It starved the rest of the users from executing their queries, which are used to power their dashboards, even though they were much faster and it took very less resource to compute those queries. Our teams started analyzing the issue and quickly found that the connection pool and the thread pool have been depleted by some long running queries. We realized that the lack of guardrails had led to a classic noisy neighbor scenario. So, the logical solution was to make sure that valuable compute and network resources like threads and connections be guarded against both intentional and non intentional exploitation. Hence, we started factoring in resource isolation as a mechanism to achieve a multi tenant system for proper quality of service guarantees and SLA. Now, we are using Apache Druid as our real-time analytics DB, and we started looking into the capabilities offered by this system to bring in such resource isolation. We identified that it is possible to do so, and by adding some checks, we can protect our connection and thread pools against exploitation. So let's go through them one by one. The first one is query prioritization. This turned out to be a very good fit for our use case as we are serving a heterogeneous workload, and this would provide a mechanism to control the capacity utilization. Also, since we are dealing with real-time data, which is time series in nature, we can specify various criteria to categorize requests or queries at runtime and assign them priorities based on the amount of resource that they might consume to compute the result. We could also specify various criteria like the length or the range of time over which the query is being executed. We could evaluate the age of data to be used to compute the query. We could also consider the size of data or the number of data files that it needs to use to compute the results. All these factors could be used to assign a query priority, and the computation of queries will be scheduled based on this priority. This would prevent any high priority fast running queries from being starved. Once the high priority fast running queries have completed, the slower queries could resume their execution. In the existing flow, all the queries, irrespective of the cost of computation, are able to fairly access the jetty throats, which are the network resources. This can easily lead to starvation of resources. So, the second check that we considered is a form of resource grouping called query laning in the terms of Apache Druid. This isolates resources such as HTTP threads and reserves a subset of the thread pool to execute only the fast running or interactive queries. We can look at it as having two lanes. One where we allow the data flow to happen for fast running high priority interactive queries, and the other one for either a high priority query or it could also run a low priority query, and it's available to both of them. With this, we are adding certain guarantees into the system that our high priority interactive queries will not be starved by any long running or slow queries. Laning works in conjugation with query prioritization to map or associate queries with a particular type of thread. But is that all we can do? Well, there is more to it. There is another mechanism which can bring in resource isolation at the process level. And the third check that we considered was service steering, which enabled resource isolation at process level. By this, we are able to classify our data hosting processes into hot and cold tiers and distribute our data according to the query needs. The query serving processes could then be divided into similar hot and cold tiers and mapped to the corresponding data tiers. Finally, we could optimize the query timeouts to encourage optimization in the query plans. Now, these strategies help us keep certain checks on the resource usage by logically isolating them on the basis of the usage patterns exhibited by the tenants of the system. With an increase in platform adoption, the challenges associated with maintaining QoS guarantees need to be addressed to avoid typical performance issues like noisy neighbor, retry storm, etc. To summarize, in our mission to become the world's largest and most customer centric omni-channel retailer, technology has been all pervasive. It has been the driving force of many innovations that define the world class shopping experience we provide to our customers. The tech teams at Lowe's have been equipped to build applications and platforms that serve our customers and enable our 300,000 associates across the US and India. And we continue to evolve on our journey of building better platforms. Thank you for being with me today. I hope you find this topic useful and it helps you build more resilience into your platforms. Please ask any questions you have on the Slack channel, and we will try our best to answer them. Goodbye.